Alright guys, so this is the Wednesday video. I did make a mistake, guys. I want you to go ahead and find, I want you to do the move on and do as much as you can on the review, but I also want you to do the assignment. Guys, get some practice, at least do numbers 1 through 4, and if I see that you did more than that, I'll go ahead and just put more points onto your paper. So make sure you turn this one in. This is the one you're turning in. Okay, so what we're going to do here is what we call the definition of a derivative. And really, everything we've been doing has been leading up to this. This is the big thing about calculus. And so this is like the first step that you do to that. Okay, so what I'm going to do here. Oops. Am I missing a page? I'm missing a page. Yes, I am. What did I do with it? Oh, it's right here. The definition of a derivative is as follows. Okay, so I'm not going to go into real big detail here, guys, of what an actual derivative is. You'll find out in calculus. It has to deal with it being a slope of something, and you'll cover that in a lot of detail in calculus. But this is the definition right here. Now, this right here is a derivative. So what I want you to notice is I have this little comma here, okay? Whenever you see that comma, that means derivative, okay? So if I ask you for the derivative, or if I use the definition of a derivative, or if I give you this symbol right here, that means do this process. So what I'm going to do is replace every time I see an x with x plus h, and then I'm going to subtract the original equation divided by h. So in the end, just so I can give you a big clue, this should cancel from the original equation, okay? And we're going to go through one here. So definition of a derivative. So here, use the definition of a derivative to find f prime 3. So I see that I have the little comma there. That means prime, okay? Or derivative. So first thing I want to do is, okay, so you're not going to plug in a 3 straight into this equation. You have to do the process first. So here, let's not use a 3 at this point. Let's use an x, because we need to do this first, okay? So the limit is, I'm writing just the definition the way we see it here. As follows. It looks like this, okay? So I'm going to write, remember, I'm going to replace with x plus h in here. So, again, I'm rewriting it, guys. But now with the equation they gave me. So, I'm going to replace with x plus h right here for the x. So, this is 3. But instead of writing x, I'm going to write x plus h. That's all I did. And I write the rest of the equation. Okay, so that's just the 3x part. I still need to put the plus 5. Okay? Now I replaced everything in here, all the x's in this original equation with x plus h. Okay. Next part is telling me to subtract f of x. So this whole thing is f of x. So I'm going to put it all in the parentheses. 3x plus 5. So all I did was replace f of x. I put a minus and I put the whole equation, what it says there. Divided by h. Okay. So now we're going to do some distribution here. So 3 times x is 3x. 3 times h is 3h. Plus 5. And then now I distribute. Negative times 3x is negative 3x. Negative times 5 is negative 5. Okay, and so really what we're going to see here is like a bunch of things starting to cancel. Okay, so I see that the 3x and the negative 3x will cancel. The 5 and the negative 5 will cancel. So all I'm left with is 3h divided by h. And I can see that the h's cancel here. So what I would do here is, if I saw any more h's, like if this had another h behind it, if I hadn't canceled them already, I would plug in the 0 for the h. But I don't see that here, so I can get rid of this now. So my derivative, my f prime of x is just equal to 3. Now they don't want to know f prime 3. They want to know f prime, excuse me, f prime x. They want to know f prime 3. So here, and now I'm going to plug in a 3 for x. Well, I don't have any more x's, so this is my equation. This is my answer. This is it. If I had an x, like we're going to see in the next problem, I'm going to plug in the 3 for the x. Okay, so let me just put everything here so you guys can copy it if you need to. And we'll move on to the next problem. So now I want to use the limit of a derivative. And again, I see the little prime here, f prime 2. So first thing is, let's find the prime of x. Okay, so that is limit as h approaches 0. F of x plus h minus f of x over h. Okay, so I'm going to write the equation. This one's a little bit easier to work with. 2 multiplied by x plus h squared. And I don't see anything else over here, so I'm done. Minus f of x, which is 2x squared. All divided by h. Okay. So, again, guys, here I just can't distribute. Remember, this is x plus h squared, so I'm going to work with this on the side. And, I mean, you can just go ahead and memorize this because you're going to be dealing with this a lot. So x times x is x squared. X times h is xh. H times x, again, is xh. And h times h is h squared. So this is x squared plus 2xh plus h squared. Just like that. So this now becomes so this whole thing became this over here, what we just finished working through, minus, I'll go ahead and distribute it, 2x squared, all divided by h. So again, now I can distribute again. Now I can distribute, okay. So 2x squared plus, oops, not 2. 2 times 2 is 4, so 4xh. And then plus 2h squared minus 2x squared, all divided by h. Okay, so now I'm going to cancel some things here. So I see that the negative 2x squared and the positive 2x squared cancel. So I'm left with 4xh plus 2h squared, all divided by h. So remember, on the last problem I told you that this h down here needs to cancel. So that's what I need to get to. I need to get to that. So I'm going to continue working with this. I see that I have an h in this one and also in this one. So if I take one out, here I'm left with 4x. So I'm factoring it out. And here I'm left with 2h, all divided by h. So now I see that the h's cancel. And I'm left with the limit as h approaches 0 of 4x plus 2h. Oops, sorry. So at this point, guys, now I'm going to plug in the 0 for h. So right here, I see a 0, an h here, so I'm going to plug it in. So this becomes 4x plus 2 times 0, which is just 4x. So 2 times 0 is just 0. So my f prime of x is 4x. Now I don't want f prime of x. What it's asking me is f prime of 2. So f prime of 2, all I'm going to do now is multiply by 2, which is equal to, oops, that's not a very good 8, but should be an 8. So this is the final answer. Okay. So I know this one's probably like a more difficult question, guys. Try your best here. Again, I'm sorry I'm not in the classroom, not by choice. But go ahead and if you have questions, you can see me after school, and I'll work through them with you all. Last problem, I went ahead and just... Oh, well, let me get this one. That way you have everything here. Okay, so on this one, this is the entire problem. I went through it. Okay, so again, I'll walk you through it here. I replace the x squared with x plus h. Again, guys, just memorize this because I'll write on the board for y'all. But you're going to use this a lot. X plus h squared is just equal to this, so that you can skip a step. You go straight to here. So x plus h squared is equal to this. And now I distribute the 4. So 4 times x squared is 4x squared. 4 times 2x is 8xh. And 4 times h squared is 4h squared. I have the plus 1, and then I distribute the negative, so negative 4x squared minus 1. I see the 1's cancel, the 4x's cancel. I'm left with this. And again, guys, this is really what you're trying to do. Factor out the h. So you should for all the problems that you're going to deal with, you should not have anything other than an x. And so I'm left with 4x plus h. I plug in a 0 for h. I'm left with 8x. And this one's asking for f prime 1, so 8 times 1 is 8. So there is a mistake on the homework. So right here, where it says find f2 for each problem, that should say, so change it to that, f prime 2. So you have to do this whole process and then plug in the 2 for x at the end. So again, guys, just do like 1 through 4, then continue with the review. And if you have questions, let me know.